In this problem, we are asked to write the equation in vertex form, and we're going to do this by completing the square. When we get to our equation, we see that our a value is not 1, so we need to factor out this 2. This is the same problem that you were working on in problems 5 and 6. So we're going to factor the 2 out from these first two terms. So that's going to be y equals 2 times x squared plus 2x. And we're going to go ahead and open up a space to find our new c value for when we complete that square. And we're just going to bounce this minus 3 down a little bit. And remember, whatever I add into this equation, I need to subtract because I need to maintain equivalence with my original equation. All right, so now we need to find this new c value, which we did in the previous problem. So that's going to be 2 divided by 2 squared, which is equal to 1 squared, which is equal to 1. So this is plus 1. And then we have to do 2 sets of that or use the distributive property. So it's 2 times 1, so we subtract 2. So that's where we got to in problems 5 and 6. Now we're going to continue to write the vertex form. So we keep our a value of 2, and we're going to take this x squared plus 2x plus 1 and rewrite that as the perfect square that we created, x plus 1 squared. And then we're going to take these last two terms, the negative 3 that was a part of the original equation and the minus 2 that we had to use to maintain equivalence when we added this plus 1 in, and we're going to combine those, so it's going to be minus 5. So our vertex form is y equals 2 times x plus 1 squared minus 5. Now, you can easily check this using Desmos. So in Desmos, graph your standard form equation and your vertex form equation. You should be getting the same parabola. Notice our a values will stay the same. And if I graph this standard form, I should see that its vertex is at -1, -5. So we can use Desmos and both forms of the equation to verify that we have completed the square correctly.